Hi, in this video we will learn how to find both eigenvalues and eigenvectors of a square matrix. So far we know how to find one of these if we know the other one, but now you have to be able to find both eigenvalues and eigenvectors of a matrix if someone gives you a square matrix. Okay, so first thing is to recall that by an eigenvalue, so lambda is an eigenvalue of A, if A v is equal to lambda v for some non-zero vector v. And well, I can turn this into an equation in which v is an unknown. So we can rewrite this thing as AV is equal to lambda times identity v. And from there we can write lambda identity v minus AV is equal to 0. It means that lambda identity minus A times v is equal to 0. So this is a linear equation with the coefficient matrix lambda minus I. And what is lambda? So we are looking for values of lambda for which the system of linear equation with the augmented matrix lambda I minus A 0 has non-trivial solution. So we are looking for such lambdas. This will be one of those questions that the augmented matrix has some variables in some entries, and well, you have to find for which values of lambda the system has non-trivial solutions. Okay, so let's see these things through some examples. Okay, I believe I have two examples. Yes, here. So the key point here is that make lambda times identity. So identity here is 1, 0, 0, 1 minus the matrix. This is lambda minus 6, 1, negative 2, and this will be what? Lambda minus 3. Yes. So then form the augmented matrix. Lambda minus 6, 1, and negative 2, lambda minus 3, 0, 0. For what values of lambda the system has non-zero solution? Well, let's just row reduce it. Here you see I don't like to do anything with an entry which has an unknown in it, because I don't know if this is going to be 0 or not. So let's just switch row 1, row 2 to be able to generate first a non-zero leading entry here. And now you can turn it to 1, but I don't need it here at this moment. Now I can make this guy 0. How? Well, I will add to row 2. First, multiply row 2 by 1 over negative 2. Well, I will do by 2 because I want to subtract. Instead of that, I will do addition. 1 over 2 of lambda minus 6. Maybe let me write it completely so that you see what is happening. So if you do that, what you'll get, this guy here is going to be lambda minus 6 minus lambda minus 6. This will be 0. Here, however, it will be 1 minus lambda minus 6 over negative 2 times lambda plus 3. Oh, not plus, minus. And while on the right hand side everything is 0, the first row stays the same. Okay, this is row reduction, yes? Now we get here, the first leading entry is in the place. We want to have a non-trivial solution. That means that we are not allowed to have any other leading entry. It means that this guy needs to be equal to 0. So to have non-trivial solution, we must have that entry. What is that entry? Let us just do it together here. 1 minus or plus over 2 lambda squared minus 9 lambda plus 18. That guy needs to be equal to 0. 1 plus lambda squared minus 9 lambda plus 18 over 2 needs to be equal to 0. Well, in other words, we need to have lambda squared minus 9 lambda plus 18 plus 2 is 20 equal to 0. And, well, that guy is lambda minus 4 times lambda minus 5 equals to 0. So lambda either is equal to 4 or lambda is equal to 5. And that is how we find eigenvalues. If lambda is 4 or lambda is 5, the system lambda I, this guy, is going to have a non-trivial solution. Okay, so these are the eigenvalues. Lambda is equal 4 or 5 are eigenvalues of the given matrix. Very nice. How about eigenvectors? Well, if you know eigenvalues, finding eigenvectors is not difficult. What you need to do here is that just this matrix that you row reduced here, plug in these values. So for eigenvalue lambda equal to 4, plug in 4 for the lambda. It will be negative 2. 4 minus 3 is 1, 0, 0. And we know that for lambda equal to 4, this guy is already equal to 0. So this will be 0, 0. Solve this thing. So this is minus 2x plus y is equal to 0. Y is free variable t. Now from there, we know that the solutions would be of the form t over 2 and t. And that means that any multiple of 1 over 2 and 1, non-zero multiple of these guys are eigenvectors. So 1 over 2, 1 is eigenvector of the matrix corresponding, while each eigenvalue may have different eigenvectors. This guy is for lambda equal to 4. How about lambda equal to 5? Okay, plug in there, negative 2, 2, 0, 0, 0, 0. From this, you solve this. Minus 2x plus 2y equals to 0. Y is equal to t. And from there, you see that the solutions will be what? First one is going to be actually t. And then the second one is t. So 1, 1 is eigenvector of A corresponding to lambda equal to 5. Well, hopefully this example shows you everything that you wanted to know here. I will try to do another example here, very quick this time, and we'll find eigenvalues, eigenvectors. So first thing is find lambda I minus a. What is I? Let me write that. So identity matrix, 2 by 2 identity matrix. By the way, this trick will work for any n by n matrix, but well, it may have, you need maybe in the higher dimensions to do more computations than just the one you're seeing for 2 by 2. So lambda plus 1. So we are trying to see for what values of lambda this augmented matrix will have non-trivial solutions. So first thing, again, lambda row 1, row 2, you switch them. Well, this is my way of doing it. You may have different ways, but you have to be careful. I'm not assuming anything, so I'm not assuming that lambda minus 1 is 0 or not. This is a negative 1. Now, so row 2 minus row 1 divide by 2 and then multiply it by negative of lambda minus 1. This way you will have a 0 here, or negative 1 minus a lambda minus 1 over 2 times lambda plus 1. 0, 0, and this is lambda plus 1, this is 2. As you can see, to have non-trivial solution, we need to make sure that this guy is equal to 0. Otherwise, that would generate another leading entry, and first column has a leading entry. The second column, if it has a leading entry, then we have only trivial solution. But here, so we set negative 1 minus lambda minus 1 plus lambda minus 1 times lambda plus 1 is lambda squared minus 1 over 2. It should be equal to 0. This yes, this has, what we have here is that minus lambda squared plus 1 minus 2 needs to be equal to 0, and that means that lambda squared, yes, lambda squared needs to be equal to negative. Well, or lambda squared plus 1 needs to be equal to 0. You use the quadratic equation or formulas, or you can see that, well, the number whose square is negative 1 is I, or it can be negative I also. Well, these are two numbers, and as you can see, we may have a matrix with real entries, but their eigenvalue might be complex numbers. And how do you find the eigenvectors? For example, so lambda I and minus I are eigenvalues. Let me just, for I, plug in I here. So you will have 2I plus 1, 0, 0. Here you have 0. We know that with I, this will be 0. So this means that 2x plus I plus 1y equals to 0, and y is equal to t. From there, we have 1 over 2 plus I 1 over 2 times t, and t will be the solution for t non-zero. This is half plus I over 2 and 1. This is an eigenvector of A corresponding to the eigenvalue I. Well, you can find for lambda I minus lambda equals to negative I. Please do it yourself and make sure that, oh, I made a mistake here. There is a negative sign here. So this will be a negative I. Yes, because when I take this guy to the other side, it will be minus I, minus of I plus 1 divided by 2. So that's how we get that. Sorry, that was a small mistake. For lambda equal to negative I, please try to do it yourself. In other words, try to solve this system. 2 minus I plus 1, 0, 0, 0, 0. That way you will be able to find the vectors, the eigenvectors for lambda equal to negative I. As you see, the game is very simple. You form lambda I minus A augmented to 0, 0 and find for which values of lambda this guy does have non-trivials.